Okay, we're finding the volume, and to find the volume, we find the area of the base and multiply it by the height. And I just want to make clear on this one. Watch, I'm going to highlight in pink what the base is. First, I'm going to highlight what it's not. Okay, it is not the thing it's sitting on in this particular case. Okay, you can't look at the base as always being the thing it's sitting on, because you could reorient this figure and it should not have a change of base, because otherwise that would change the ultimately the numbers, how you calculate the numbers, and they should all calculate out to be the same no matter how you rotate it. So now I'm going to highlight what it actually is in pink, which is this triangle. And remember, there's two bases, and this triangle right here. Okay, and the bases, there will always be two bases, and they'll be parallel to each other. And hopefully you can see them as we move forward. The sides are straight at 90-degree angles. I use my laser pointer here, right? So from this vertex up to this vertex up to this vertex, you're forming 90-degree angles in here. Oops. 90-degree angles in there all around, right? And that's going to be a defining feature of what's a lateral side versus the bases. So, okay. So what we've got then as a base, and we've got to try and find the area of it before we can multiply it by the height, is, okay, we've got, since it's equilateral, and you can see those three segment marks right there, right there. Okay, those say that it's equilateral, and therefore it's equiangular as well. So what we've got then is we've got, for each 60 degrees. Yeah? Okay. So knowing that, if we were to try and find the height of this triangle, because remember it's base times height, and so if I drop this apothem length down here, okay, we've got then no longer a 60-degree angle up there. We've got a 30-degree angle and a 90-degree angle. Here we've got a 30, 60, 90 triangle. So if we know that this entire base side is 6 centimeters, which we do because it says it right there, then splitting that right down the middle, because it's essentially, we can treat an equilateral triangle like an isosceles triangle. In an isosceles triangle, if you drop the height down from that height, the vertex point, you're going to form 90-degree angles and split this opposite side into two equal parts here and here. Okay? And so therefore, if the whole thing was 6, then this little section is 3, and then the height of this thing, because this is the short leg of a 30, 60, 90, this side of 3, we can, since it's opposite the 30-degree angle, we know it's the short leg. And you always take the short leg and multiply it by root 3 to get the long leg. So then this longer leg is 3 root 3. Okay? And now if we want to do the area of this triangle, we essentially have the base of 6. Remember, even though we use that measure of 3 to find the height, we actually have an entire full base of this triangle of 6. So let's write that in totally across 6. And so you do 1/2 base times height, and you say 1/2 of the 6 times the height, which is 3 root 3. And we get half of 6 is 3. 3 times 3 root 3 is 9 root 3. So we have the area of that base of 9 root 3. And we multiply that by this height. The height is determined by the lateral faces that run from one base to the other base like that. Okay, so this side right here running from one base to the other base is 18. So we do that times 18. And we've got 9 root 3 times 18. So 9 times 9 is 81. So 9 times 18 is twice as much as 81. So that's 162. And it's 162 root 3. And the units are centimeters cubed. Now, I've spoken to some kids in class. I have my iPad with me. I don't have my computer to be able to check what it says, the book answers. So if this says like a decimal number in the book, then it's going to be, should be equivalent to 162 times root 3 is approximately 1.732. Okay, so multiply those two numbers together and see if that's close to what the book answer is. I'm going to give it to you as the radical, 162 root 3. But since root 3 is approximately 1.732, then I'm going to let you do that calculation to see if the book gives you a decimal answer. These should be equivalent values. Okay, anyway, sorry that took a little while, but we'll move on a little more quickly through the other ones. Okay, so this one's pretty easy because we see that these two faces are, these two sides, the legs of this right triangle are equal. So they're 3 and this is also 3. And what we'd have to do is we have to take the base times the height, and if we have a 90-degree angle, the two legs will be the base and the height. So we can say 1/2 base times height, or 1/2 3 times 3, and then you do that times the height. You do that times the height of the triangular prism. So there you go. So we have 3 times 3 is 9. I'm doing this the whole numbers first. 3 times 3 is 9. 9 times 5 is 45, and then you're taking half of 45, and half of 45 is 22.5. What are the units? Feet times feet times feet, which means feet cubed. Okay, see, it's going faster. Let's do the rest. Okay, so we've got 1/2 base times height, and we have, for this triangle, we've got a base of 12. So we do 1/2 times 12. 1/2 times base times height of 20. And of course we have to do the whole thing times the height of the triangular prism. And hopefully you can see that the height is this right here, running, as I said, between the two identical sides, in this case triangles. What's that side that runs between them? It is 6. Okay. So we can do half of 12 is 6. And 6 times 6 is 36, because I can do this out of order. 36 times 20. 36 times 2 is 72. And I got to add a 0 because it wasn't times 2, it was times 20. Okay? And what are our units? Our units are going to be millimeters cubed. We're finding volume, so it's always going to be units cubed. All right? And we've got one more to go. So the base is a 45, 45, 90 triangle with a leg of 5 inches. So I'm going to sketch it because I always think that it's a good idea to make a sketch. Okay? The base is a 45, 45, 90 triangle. Okay? And that means that if this leg is 5 inches, then this leg is 5 inches as well. And then the height is going to be 1.8 inches. Okay, so we do 1/2 base times height, and it says the base, it's got legs of 5 inches each, so 1/2 times 5, base times height, times the height of the prism, which is 1.8. Okay. Now, I'm going to do 1/2 of 1.8. I'm going to pair actually like these two together and these two together right now. So half of 1.8 is 0.9 times, and 5 times 5 is 25. Okay. We can calculate this over on the side. I don't know what this is going to do, so let's see. I mean, I do, but let's just see. Okay. 25 times 0.9, 9 times 5 is 45, 9 times 2 is 18, plus 4 is 22. And there's no need to multiply by the 0 here and get a string of zeros. It doesn't add anything to add any value to our calculations if we write a bunch of zeros there. So what do we got? Well, we've got one digit that should be after the decimal place, and that's right there. What I mean here is, in our original problem, we had just a single digit that followed a decimal point. So in our answer, we'll have just a single digit following the decimal point. Okay? And that was all the calculations. That was leg of 5, 45, 45, 90. So the two legs will be the base and the height. So we've got like a base and the height of that triangle. 5 times 5, that's 25. And this 1/2 times 1.8 is 0.9. So doing those multiplied together, you get 22.5. And what are the units? It's inches. So we can say 22.5 inches cubed, because its volume is always cubed. All right. Oops. Let me box this out and we'll be done with this problem. Hopefully those were helpful.